Hello YouTube, welcome to this installment of the Avion blog. So today we're going to take a look at a slightly different meter from what you're accustomed to seeing here on the Avion blog. We're going to take a look at something called a process meter. And today the Fluke 789 process meter, or multimeter and loop calibrator, whatever you want to call it, but they call it a process meter. Now the 789 was the second in a generation of multimeter combined with process meters that Fluke released, and they've actually been very successful. If you work a lot with calibrated loops, 4 to 20 milliamp loops, you'll know exactly what this is. If you haven't, hopefully by the end of the video you'll have a slightly better understanding of what a loop calibrator does and what it's capable of doing. Now a lot of people see calibrator and they think, oh, I can use this to calibrate my multimeter, and no. Yeah, well, you could, but no, that's not what it's designed for. What this is designed for is for calibrating 4 to 20 milliamp current loops in industrial process control systems, etc. And how that works is it can either simulate a current source or it can simulate a power supply and current source. In 4 to 20 milliamp loops, think of the transmitter or the sensor as a 4 to 20 milliamp current limiting device. So at 0 it's at 4 milliamps, and at 100% it's at 20 milliamps. So all your sensors will work within that range. What that basically means is 4 milliamps is empty, 100 milliamps is full. If you're doing a gauge of a tank, for example, a level gauge for a tank, 4 milliamps empty, 20 milliamps full. And obviously the receivers are designed to receive that. Now these can measure and simulate, and they can source those signals onto a loop. So you can basically tell the receiver and test the throughput from your process meter along the cabling to the receiver in the control room and make sure that's all working. And of course you can also test your transmitters, etc., and just see if they are sourcing the right current and whatever the case may be. This can act as a receiver or transmitter in the circuit, and you can simulate and test and do all what you need to do using this device. Now I'm making this video after I've already shot the footage of this meter, and something that I forgot to show you guys, which is quite important if you're not sure about it, is that this meter can also be placed in, put the power through, and of course do the readings from a transmitter. So it can act as the receiver. I didn't show that quite in the video, but you guys get the gist of it by watching this video. So if you don't know much about industrial automation, watch the video. It might give you a bit of a broad spectrum understanding of how it works, and I will be releasing a complete video explaining the 4 to 20 milliamp loop circuit, how it works, how the 250 ohm resistors, the heart resistors, etc. work, and all the other nonsense that goes along with it. But that'll be in a later episode. For now, have a look at the Fluke 789 and give us a thumbs up and give us a like and follow me. I intend to make a lot more reviews of the equipment, including some of the biggest stuff that I have on hand, which I've never reviewed in the past, such as the Fluke 192, etc., and show you guys some of the nice high end of the Fluke market and of other brands, of course. I am chatting to Unity in South Africa, which is 3D agencies, in the hope to get some equipment to test for video, but I'm not sure how that's going to work out. We'll see what happens. If we do manage to get some of those meters, you'll be very impressed with some of their new kit. Let's put it that way. I know a lot of people have been disappointed with offerings that come out of China from Unity, but the stuff that's being imported into South Africa under 3D agencies, the quality and the build control on those things is outstanding, and I'd like you to see them. So let's get on with the review and the first look of the Fluke 789 process meter. Alright, so today we're taking a look at the Fluke 789 process meter. Now, a process meter is a little bit different from a standard multimeter in the sense that you get process calibrators, universal calibrators, etc. This is more a loop calibrator, but we'll get into loop calibration in another video. So I'm just going to review the actual meter and the build quality, etc. Now, this meter is based on the Fluke 189-187 chassis, which is a very well-made, robust chassis in my opinion. And this was also one of Fluke's first meters or process meters to include a digital multimeter as one of its primary core functions. So basically what that means is this thing has the basic multimeter functionality as well as the loop calibration functionality. Now it won't do heavy current measurements as far as I'm aware. I think it'll do up to a couple of milliamps basically. I'm just checking here. You've got DC, AC, whatever the case may be. Yeah, that's pretty much it. Then over here you've got your resistance, etc. You've got your diode test and resistance, diode, resistance. So that's pretty much it, which also with the resistance you'll get the continuity test. Then you've got your millivolts DC, your volts DC, your volts AC. Okay, so it's got most of the basic functionality. Over here you've got your milliamps A, DC in this case, and if you look on the bottom when you start measuring milliamps, you'll see it actually has the percentage reference based on a 4 to 20 milliamp loop. Like I said, we'll get to that in a later stage. Then of course it can also source, i.e. it can supply the power. It can basically be the power 24 volt power supply in a loop, and of course it can source the current level, of which you can set your levels that you want. Of course it can simulate or read as well as source. So you can source or you can simulate or read. In other words, if you've got a 24 volt power supply already running, you can just put this in and it'll simulate a sensor. Okay, or it can source and be the power supply for the loop. That depends on how you want to use it. And of course it can also receive, basically see what the loop is doing using that function over there. Then of course you do in this mode here, this is your basic one, and in this mode you can do various sweeps, etc. by changing your mode using the blue button. You can see there you've got different modes that you can do, which we'll go through at a later stage. And then of course here again we're doing measurement, loop, power, etc. And then of course you've got the 250 ohm heart resistor in there as well. So for all intents and purposes, this is your source and your simulation, which will output between 0 and 24 milliamps as per the spec. And then you've got a measurement point over there, and of course you can add your heart, remove it, and then you've got another measurement cycle over there. So those two are pretty similar for all intents and purposes. This meter also has a pretty good backlight. It's got a dual level backlight, same like some of the high-end meters. You've got min-max functionality, range, hold, frequency measurements, all the usual niceties, the beeper function, and then of course a lot of these buttons are aimed more at the source calibrator, the process meter functionalities, where you can source or simulate, and of course you've got your steps, percentage, coarse, fine, and of course this is large steps, and then of course this is quick jump between 0 and 100%, and yeah, that's pretty much it. So on this review, what we're going to do is we're going to take a look at a few of the function sets. Volts AC, we'll do some volts AC measurements and see what we can display on volts AC. There you got your volts AC, and of course you can do your frequency of your volts AC. I don't know why it's holding up like that. Maybe because it's not seeing something, I don't know. And then you got your volts DC, okay, which is just your basic volts DC. You can again adjust things as you need to. Then of course you got your millivolts DC. Then of course you got your continuity, your resistance. We'll go through a few resistors with that. It looks like you can do up to 40 mega ohms. Measurements, we'll do some measurements. I'll use another loop calibrator to simulate onto this one so we can see exactly how the function sets work, and we'll do all those sort of functions there. So step one, let's measure some AC voltage. So in order to do that, the first thing I need to do is pop a set of leads in here. I'm just going to take a generalized set of multimeter leads and pop them on to the standard multimeter function ports of this meter. Okay, so we're going there. The first thing we're going to do is we're going to go volts AC, and we're going to do a mains measurement and see what we get. So let's connect it up to the mains. Try not to die in the process. And there you got your 233.7 or 234, it fluctuates, volts AC. No problems at all. Little lightning bolt giving you a warning. Happy with that. I could do other measurements with volts AC, but I don't really see too much point of it. Volts DC, 3.3 volts voltage reference. Pretty much spot on. I'm happy with that. I'm going to do a comparison now. Okay, no, I'm not. It just seems like a waste of time. So there you've got your 3.3 volt voltage reference. My new voltage reference is in the mail. So we'll do more in-depth testing in future of all of these things. So I'm quite happy with that. We've got our millivolts DC. It would be nice to have a millivolts or a voltage calibrator at the moment. I don't, so I'm not going to go into doing that and testing the accuracy of it. Resistance and continuity, it doubles up. So you've got your resistor, and you can see 0.2. If you push this button, you'll go to continuity. Just like Fluke, it's fast, it's reactive, and it's latching. So I'm happy with that. So we're going back into the resistance mode. Let's do a low value or lowish value resistor. First thing we're going to do is we're going to connect our leads together. Remove that. Check. We expect about 1.1 ohms. And there it is, 1.1 ohms. Happy days. So that looks spot on accurate. We can check other things such as diodes using the diode function over there. I'll just grab a silicone and a germanium diode just for testing purposes quickly. And of course, we'll probably also throw an LED at this thing and just see what happens. So let me grab one of those. Get a red one because they're nice and viewable on the camera, and I'm back. Right, so we got a germanium diode over here. In reverse, I'm not going to worry about because reverse, you will, there you go, see nothing. Forward, 0.120. Silicone, forward, 0.5 to 0.7, there it is. And of course, an LED. Maybe, just maybe, there we go, 1.796, and yes, it does light the LED. So again, well done to Fluke on having an almost full-on featured high-end multimeter within their precision, well, within their loop calibrators. I'm very impressed with that so far. Okay, milliamps and the current side of things over here we're going to look at completely separately from the general multimeter functions. So we've gone through and covered most of the multimeter functions. I haven't done the min-max thing. What the min-max function basically would do is, let's just throw this onto a power supply. We'll push the min-max button. We'll throw the power supply on. We'll run it up. Okay, but it's in manual ranging at the moment. So if we're expecting higher voltages, let's range it up. Okay, now min-max. You'll see it'll hold the max that it's seen, and even if you switched off the power supply, that max will hold. And then you can come through here and you can see minimum 0.06, the min-max average over the time. It'll be going down now because I've disconnected the power supply, and yeah, here was your maximum reading. So max, min, average, current. Max, min, average, current, and yeah, your average will drop off until it's pretty much 0 once it gets there. And yeah, that's pretty much what you would expect from a min-max function on any Fluke multimeter. So let's get along now and check out the loop calibration side of the 789 process meter. So now where these loop calibrators really excel is, let's first start with sourcing. Okay, if you look here on the thing, it'll show you source. Positive would be in this point over here, negative would be in this point over here. So basically now what I'm telling this meter is it's going to supply the current limiting 0 to 24 using the Bryman as a milliamp meter, but I'm also displaying the percentage so you can see on the process calibration how these things work. So we're going to go to source. Okay, so right now this meter is outputting 24 volts. Okay, and to confirm that, we're going to go from here. We're going to come in 2 volts DC and we're going to check. Oh, okay, 31,490. So to simulate for a loop and voltage drops, obviously it's a bit higher, but we're simulating a 24 volt circuit. Go back to where we need to be, and the moment we're at 0%, so we're sourcing 4 milliamps, so the receiver would see this as 0%. As to why, quite simply, if 0 milliamps was equating to 0%, then you wouldn't know if there's a fault condition, in other words the circuit is broken, or if you're empty tank, in whatever case may be, and that could be dangerous. So 4 milliamps is rated as 0. Think of all loop circuits in the 4 to 20 milliamp range that operate within that range to be 4 amps is 0% and 20 milliamps is 100%. So if it's a tank sensor, it'll be 4 milliamps if it's empty and 20 milliamps if it's full. So right now we're at 0%. You'll see the Bryman's reading 0% and it's reading, well, technically 4 milliamps. Okay. Now with this meter you can fine tune that by going up to 4.001 milliamps, and let's get up till we see, and then you get to 0.1. This is reading a little bit differently, but you get the gist of it. Okay, or you can go up in 100 microamp steps. Okay, you'll see it there, 0.6, 1.3, 1.9, and so on and so forth. So you get the gist of it. And of course you can go up in 25% steps, so that's 25%, 8 milliamps, 50%, 12 milliamps, 75%, 16 milliamps, 100%, 20 milliamps. Okay, that's all 100%, and that's the way it does. And then of course you can quickly shoot between full and empty at the touch of the 0 or 100% button. So now that is, this Fluke is actually creating the voltage for driving that 4 to 20 milliamp loop circuit. Okay. Now the other function of course is the simulate function. Now if I was to move this across to the simulate right now, let's do that. Simulate negative is here, simulate positive is here. Okay, no voltage, so we've got nothing. So how would you get voltage running on there, for example? Well, that would be quite easy. We need to create a 24 volt power supply. So this would be used now if it was in an active circuit. So what I'm going to do is I'm just going to run up the bench power supply to around 24 volts. Okay. And just for safety's sake, we are going to apply some current limiting. Not that it's really needed, because the Fluke should limit that current. Okay, then we're going to run the power supply in, through, and out. So basically what's happening here now, okay, the current's running the wrong way, but let me just check that. We got positive going in, we're going out, on the okay. See, we need to just swap some things around over here. Not that it's very important, but let's just do it right. Okay, so right now this is limiting the current on the supply to 4 milliamps. Okay, and again we've got an active power supply coming in here. This meter is not creating the voltage, so we've created a loop circuit, and of course now we're using this meter to control said loop. And there you got the exact pretty much same function set again, just that you now in control of, you're no longer controlling the voltage in the loop from the Fluke. It's now coming from the circuit that you're working within. Okay, now the second function over here we spoke about, you'll see it's ramping. Now this one ramps up all the way through the digits, and then it should ramp down again. So it'll get there, 100, and then it'll come down again. Then the second option is it'll ramp up, down, whatever the case may be. Twice basically. Then the third option I'm not quite sure how this one functions. Fourth option, different ramp options basically, but yeah, you get the gist of those ramping. Okay, you can also use the meter for measuring, like what you're doing with the Bryman over here, which is great because it gives you full control over everything in the process control current loop sort of environment. So that's the gist of it, pretty much what its purpose is as a loop calibrator, and also a bit of a crash course in industrial control loop circuits, etc. We are busy setting up a video teaching more about industrial control loop circuits, 4 to 20 milliamp loop circuits, but there you get the gist of how the meter functions and what its purpose is in life. Like I said, it can be a multimeter, but I wouldn't go out and purchase this meter if I was looking for an electronics bench multimeter, because it wouldn't serve the purpose as well as, say, a Fluke 189 or any of those. But in so saying, it's still a very capable multimeter. It does have a lot of function set, which I really think is brilliant and definitely worth an investment. Now, these meters are pretty, again, like I said, solid. They have quite a nice function set. And of course, the way they operate with batteries. Let's just show you that quickly. Okay, we got a loop calibrator here. Sorry, I actually have two of these around at the moment. Basically have these, and you just basically pop that around, and then this just slots out there, and then you can replace your batteries and your fuses, etc. It takes 4 penlight batteries, and the battery life is generally pretty good on these devices, so your batteries will be good for a couple of months, depending on how much use you get out of your calibrator. And yeah, that's pretty much it. There's not a lot to talk about with these meters, and I'm not going to worry too much about accuracy. I just wanted to show you the Fluke 789 process meter, and you guys can decide whether this is something that you'd want to purchase or not, or if it's something that you would use in your fault finding process. So guys, thanks for watching, and again, until next time, have a brilliant one and take care. And there we have it. 4 milliamps being output from the 789 process meter, 4 milliamps being read on the Fluke 287. Yeah, it seems to adjust, but even if you'll see here, it's pretty much on the ball here. Once it settles, there you go. Spot on the amp side at least, and I like that. Milliamps are reading clean. I can't output microamps on this, so yeah, that doesn't help much, but not bad at all. And in fact, we're putting out 4,999.5 microamps, and we can adjust this slightly. And as you can see, the accuracy is ball hairs off. Yeah, hardly even worth a mention, eh? So, yeah, I'm very happy with the calibration of the Fluke 287 on the current scale. And we're now checking the milliamps calibration on my 867 Bryman. And everything looks pretty flippin' good there, if you ask me. So, happy motherfucking days. That's 100%. So yeah, this is something that's a little unknown fact about these Bryman meters, although they're not process meters. The fact that it's got that process meter 100% output, we go to 75%, there it is. It can read the process meter values. How awesome is that, ladies and gentlemen? I'd say pretty freaking awesome, if you ask. Yeah, we're reading the output from the process meter Fluke 789 in the microamps range, and we're getting 3,999.2 microamps, pretty much on par with the Fluke 287. Everything's looking fantastic. Here we have the Fluke 177 reading milliamps. Don't expect it to be anywhere near as accurate as the 287 or the Bryman, but there it is. And we go to 8, looking good. For what it is, it's looking pretty damn good. I can't complain too much about that. It definitely does the job. So, happy days. Girls, here we have the Fluke 789 process meter feeding its closest cousin, the Fluke 189 True RMS Multimeter. And again, my milliamps are looking pretty damn good. I'm happy with that. Very chuffed, in fact. Very, very chuffed. Very nice, Peter. Now we're going to go microamps. And we should read, wow, this one's the closest to that value all the way. But very nice. Very, very happy, Peter.